Dear students, welcome to bridge rectifier practical experiment. Now what you are seeing is the bridge rectifier circuit. Here bridge, 4 diodes are connected in a fashion of a bridge. So we the name bridge rectifier. This is also one more type of a full wave rectifier. This is the AC input voltage. The output voltage is the full wave rectified output, pulsated DC. The difference between center tap full wave rectifier and the bridge rectifier is, if you observe, the transformer is an ordinary transformer instead of the center tap transformer. Because this is very cheaper one, the bridge rectifier is becoming more and more popular nowadays. Now AC input voltage is applied to the primary of this. So if you measure the voltage across the load, we will get the pulsated DC or unidirectional. So AC is converted to pulsated DC. The ripple factor for bridge wave rectifier also remains the same at 0.48. We don't want this, we want a pure DC, almost pure DC. So what we need to do is connect a capacitor across the load resistance, Now let us see how this will change. The output voltage waveform, it will change like this. This is almost like almost very close up to the straight line. Instead of this pulsated DC, this is better. So if you use the different value of capacitors, this ripple can be reduced further. Now let us come to the hardware. Now here is a transformer. We don't want center tap, so we are using 0 to 9 volts. A bridge rectifier, so there are 4 diodes connected in a bridge fashion. 4 diodes, 1, 2, 3, 4 diodes. AC input voltage is applied to the 2 edges, 2 branches here. Output voltage across the output, here at the other 2 ends of the bridge, a load resistance is connected. Here the capacitor is connected, not still it is connected, it is simply connected there. Later I will show you the capacitor connection. So there is a transformer, there are 4 diodes and the load resistance. So difference between center tap full wave rectifier and bridge rectifier is, here there are 4 diodes, in center tap full wave rectifier 2 diodes. There we need center tap transformer, here we need an ordinary transformer. Now let us see the input voltage, what is applied to the bridge rectifier. So here at the secondary of the transformer, here this is the input voltage. Let us see output voltage. This is the rectified one. This is the pulsated DC, but still AC component is there in the DC. So you can observe only positive half cycles. Keep looking there. I will connect the capacitor. Capacitor acts as a filter to remove unwanted AC component. See how it changes. Now see the output voltage waveform, a beautiful waveform which is very close to the DC. This can be used. The ripple has been reduced. So these are the input voltage waveform and output voltage waveform. Now let us try to measure the ripple factor. Ripple factor is the ratio of RMS value of the AC component to the DC component. So let us try to measure AC. Now this is the bridge rectifier without filter. The AC and DC voltages are measured across the load resistance. Here is the load. This is the AC voltage, 4.1. I will take it as 4.1 AC. Now let us measure DC. It is 7 volts. The multimeter terminals have changed, so it is showing negative. Don't worry about that negative sign. So AC by DC, definitely you will get almost 0.48. So once again I will go to AC. Now let us measure the ripple factor with filter. Now I will connect the capacitor. Earlier you know the value of AC. Now see how drastically AC changes. AC voltage is almost 0.07. This removes AC. At the same time, let us see the DC value. DC value, it is 11.74. If you don't want to see that negative sign, I will change the terminals of the multimeter. Now you can see 11.76. So AC by DC ripple factor value will be 0.000 something. That means ripple factor has been reduced. So by using a capacitor filter, you can remove the unwanted AC component in the DC output voltage of the rectifier. This is about the bridge rectifier. Thank you.